the role is quite simple. Whenever someone in Java just says @Mike or whatever, just pop in the queue and relay that so people can hear it. We'll do our best to keep an eye on the conversation as it progresses, but it's easy to miss things. Thanks, Lucas. Appreciate it.
You have 2 scribes in the chat.
Okay, why don't we get going? Welcome everyone to the first meeting of the week. Asque, thanks for being here. It's quite early for some of us, so hopefully this is a productive session nevertheless. Typical, this meeting is recorded. You've used this tool before. If you used this tool before, you know how all the buttons work at the top. But if you've not, it's fairly intuitive. If you want to join the mic queue, just press the button. You do have to unmute yourself to talk and share video. Otherwise, typical IETF rules apply in terms of queue management. And as a reminder as well, just state your name at the mic just so the speaker knows who you are and the note taker can jot it down. This is the note well. Probably have not yet seen this week because it's the first meeting. You're expected to be somewhat familiar with what's here. I want to take a moment to briefly call out the code of conduct. In essence, what we are looking for is people to be, professional, respectful, and courteous to others in how they engage and discuss technical details. We are an international standards body, meaning that we do get people with different views, different ways of delivering, and different ways of receiving feedback. So we just ask as chairs to, please do your best to keep things impersonal, focusing on technical details, and just be respectful generally. We've not had any issues in the past, thankfully, because everyone who participates in this group is are fine engineers, exemplar members of the IETF. So hopefully we can keep it that way moving forward. Eric, do you have anything else you'd like to add? Cool beans. Okay. Here's some links. The agenda is up. It's also here in the slide deck. We have a note taker. Thank you, Robin. JavaScribe. Thank you, Lucas. And here is our agenda. First up, we're going to talk about ConnectUDP and HD datagrams. David's going to give those presentations, and then Tommy's going to speak to ConnectIP, the unified proposal based on the 2 drafts that were presented during the last meeting. And then as time permits, we'll talk about 2 new work proposal items, as ping from Ben and prioritization from Lucas. Quickly pause here to see if anyone wants to do any rearrangements or refactoring. Okay, if not, let's proceed. I will stop sharing, and David, I'll hand it off to you.
Thank you, Chris. Let's see, ask to share slides. All right, can you see the slides?
Yes. We're all set.
Awesome. All right. Good morning, afternoon, evening, absolute complete middle of the night, everyone. My name is David Skenazy, and we're here to talk about Asque. More specifically, this presentation, I'll be talking about both the HTTP datagrams and the ConnectUDP draft. So, first, a quick recap for if anyone is new to Asque in the room. So the main goal of these two drafts is to build ConnectUDP, which is like Connect, which is the TCP method for proxying, sorry, the HTTP method for proxying TCP, but for UDP. And in our discussions of requirements over the now 2 years almost that we've been working on this, we want this to work over all versions of HTTP and across intermediaries. And when we're working over HTTP3, we really want to leverage the quick datagram frame, which is an extension to quick version 1, which is currently undergoing IESG review. And since, as we started working on this, this was all in one draft, but we realized that there were other features or applications such as web transport that were interested in using datagrams of HTTP, but not specifically in ConnectUDP. So we split it into two drafts. So some other working groups could depend on the HTTP datagrams draft without depending on the ConnectUDP draft. So earlier in April this year, we had an interim to focus on HTTP datagrams, and we kind of redesigned everything. After had some discussion on the list, and then we merged some PRs, which was great. And then at the next IETF meeting, we redesigned everything again, which is also great. But it is causing quite some churn in the drafts. So hopefully, our goal today is to, if we're redesigning things again, fairly, reach some point where we have something that everyone likes, so we can then move on from there. Because there are folks who have this in production, and it'd be good to get to a place where the drafts are more stable if we all find a design that everyone likes. As of the ConnectUDP draft 6 and HTTP datagrams draft 5, we have 3 working completely independent implementations right now. The Cloudflare quiche one, the Ericsson one, and the Google quiche one. And both Google and Ericsson have client and servers, and Cloudflare has a client. And we reached successful interop with all of these at the hackathon last week. So good news, things work. Then let's see where we were kind of based on these prior meetings. So a big part of the redesign that we did back in April was to have a strong and tight coupling between HTTP datagrams and HTTP request streams. So think of it like a sidecar, where the main motorcycle, the main thing is your HTTP request, which in Quick, for example, those are on client-initiated bidirectional streams. And the idea is that datagrams all are associated with one such stream. They don't exist in a vacuum, and that makes it a lot easier for everyone to reason about datagrams and where they live in, regards to HTTP semantics. We also landed on the capsule protocol, which is a way to send information end-to-end between endpoints, even if there are HTTP intermediaries along the way. And the capsule protocol is as simple as you can kind of get it. It's a sequence of TLVs. It's inside the data stream. And by data stream, I mean for HTTP 2 and 3, what's inside data frames. And it's in HTTP 1, that's just the main stream of data for a connection. And additionally, one specific capsule that we define is the datagram capsule that carries an HTTP datagram. And in particular, that's useful for versions of HTTP that work over TCP, so HTTP 1 and 2, because you don't have the quick datagram frame there. So that's how you convey HTTP datagrams for those versions. And then in terms of encoding for the quick datagram frame, the like what at the quick layer is the payload of a quick datagram frame, starts with a varant, so a RC9000 style variable length integer, which has the stream ID divided by 4, and kind of the tweak of that encoding is because client-initiated bidirectional streams, which are the request streams in HTTP3, are all divisible by 4. So we just divide it by 4, and that saves some bits. And finally, because that encoding could, potentially change down the road, and also changes the semantics of what we see in quick datagram frames, which didn't have semantics before, we negotiate that with an HTTP3 setting. All right. Now, where are we today? So we had some good discussion on the list last week. Thanks for kicking things off, MT. And one of the things that we realized there is, while there are some parts that we're reaching good agreement on, such as most of what I just talked about, the bits about extensibility and how you demultiplex aren't quite clear, or quite full agreement yet there. So I'm kind of going to walk us through what we're trying to do with those, what our requirements are, and kind of explain the current design and how we could potentially change it. So yeah, I'm going to go through that. Apologies if this is kind of a long ramble. It is the complete middle of the night over here in California, but I will try to be as clear as possible. Feel free to jump in, especially with clarifying questions, but then once I'll have gone through some set of slides, I've definitely left a lot of time for discussion to make sure we get something that folks like. All right, so this is a set of extensions that have been discussed in or around the working group of protocols that use HTTP datagrams. So to be clear, I'm not saying that let's not try to figure out if those extensions are a good idea or if there's something we want to build. They're just random ideas that exist. And because they're out there and some people are passionate about them, maybe we should make sure that the protocol is extensible enough to allow building them down the road. So we're eventually going to build Connect IP, and there is interest in being able to compress the IP header in Connect IP. Similarly, in Connect UDP, some folks have expressed interest in being able to speak ECN, or if there is ECN between the proxy and target, to be able to convey that on the encapsulated path between the client and the proxy. Or similarly, if the proxy receives an ICMP packet that refers to that 5-tuple, being able to let the client know about that is an extension that someone wants to build. Otherwise, there is interest in doing PathMTU discovery for HTTP datagrams. So because the quick datagram frame can't be fragmented, it has a maximal payload size, so an MTU for datagrams. And there is interest in being able to figure out what that is. And that would be an extension. So Ben has a presentation about his proposal there in the end, as time permits section. So I won't need to go into too much detail, but there's interest in doing this at the HTTP level as opposed to at a higher level. And then over in web transport, there's discussion of conveying priorities, where potentially instead of just, you can always prioritize any data as you're sending it, but being able to tell your peer how you want to prioritize it is something that we might want to be able to do for different types of data grabs. So the reason I kind of selected these extensions in particular is right now we're building a way to send HTTP datagrams, which okay, we're sending these data payloads, but it sounds like there is interest in being able to send multiple different types of payloads at the same time, and that means demultiplexing. So let's say if I'm sending a Connect IP uncompressed full IP packet, and I'm also sending one that is compressed, I need a way to tell my peer, oh, when you receive it, this one is compressed and this one is not. So that's where we get into demultiplexing. We need a way to tell between these different formats that we have on the wire. And a simple way to do that is by having an identifier that you send at the start of each packet. But the big question here that has come up on the list is, why do we need to care now? can't we just say, these are extensions, we'll deal with them when we're done? And that is absolutely a reasonable approach. We want to keep the core protocol ideally as simple as possible. But we want to make sure that we don't paint ourselves into a corner. We want to make sure that when we go to build these extensions, we don't look at what we have and go, oh, if we had just done this bit slightly differently, we would have been able to extend this easily, but now we can't. So I think it's valuable to have this discussion right now before we publish this, to make sure that whatever the extensibility knob or the extensibility foothold, if you will, that we need is in the core protocol. So that, as our favorite thing, is a good segue into kind of requirements. What will we want for these extensions? Actually, one second. Coffee. So the first goal for this specific one is this idea of demultiplexing. We can have multiple formats that coexist simultaneously, and we want the receiver to be able to differentiate between them. Another requirement is, we're working across intermediaries here, and often intermediaries don't get updated as often as endpoints. So as we've seen, with other protocols at the IETF, the fewer machines you need to update, the more successful your protocol is likely to be. It was a lot easier to deploy quick than IPv6, for example, because if you only need to modify the endpoints instead of everyone along the way, you're in better shape. So the way that applies here is, if we can have a way that we can deploy extensions by modifying the client who wants it and the proxy who wants it without having to modify all the intermediaries, that's a big win. Another requirement is there is some interest, like the MTU discovery extension, for extensions that apply to multiple protocols. So I'm saying protocol or application independently. I mean like what sits on top of HTTP datagrams. So that right now the main ones we have in mind are ConnectUDP, ConnectIP, and WebTransfer. And there is some value. Like this one isn't absolutely obviously required, but if we have a way to write this once and for all of them, that could be useful. And then another requirement that we didn't really set off with in the first versions of HTTP datagrams, but that became very clear this year, was that we want to make this mechanism optional. There are implementers that don't want this feature today and really want to get things out the door as simple as possible. So they really want to be able to pretend that if we build the system into the core spec, to pretend it's not there. So that means, not only optional to implement, but also that they don't need to reason about too many concepts to be able to implement the core spec. And then a final design requirement is what I've been calling zero latency extensibility, which is the fact that we're to allow using extensions in the first application flight. I have some slides to explain into more detail what that means exactly. All right, so on the topic of supporting extensions, one important property here is if something is not mandatory to implement, or if it's an extension, that means that not everyone will implement it. And one of the design properties of HTTP is when the client wants to send its request, it doesn't know the full feature set of the proxy that it's talking to. And you can't use settings to negotiate feature capabilities because there could be an intermediary between the client and the proxy. So, and that's a common thing across all of HTTP. That is one of the design constraints that we kind of inherited from deciding to build Mask over HTTP. And waiting a full round trip between the client and the proxy to get the HTTP response, which could negotiate the support for an extension, is unacceptable. Like we're in 2021. Latency is the most important performance metric for pretty much everything we do, and we need a way to be able to use things optimistically and fall back. If they're not supported without everything breaking, we can't burn a full round trip to wait for these things. All right, so what do I mean exactly by zero latency extensibility? Well, what's zero latency setup? So this is a pretty standard scenario where you're just doing, the client wants to do connect UDP to a proxy, and then inside those UDP payloads, it wants to speak quick to a target server. And one of the design choices we have in Connect UDP, which technically is also possible in Connect, but is you send your Connect UDP request, and alongside it, maybe even in the same packet, you can send an HTTP datagram that contains your quick initial to the target. And if the proxy accepts it, it'll send a 200 OK back to the client, and at the same time, it'll receive that quick initial and send it over to the target. If the proxy decides to reject the request, it'll just silently drop that quick initial, so there's no harm, no foul. But you've just saved a round trip between the client and proxy. You don't need to say request, response, and then send the datagram. You can send it optimistically, knowing that if for some reason it's denied, it gets dropped, not the end of the world. And again, that is user visible latency for that end-to-end quick connection between the client and target that is being saved. So big win there. So now, Ian, what's up?
On the last one. So I'll just go back one slide if you don't mind. So my understanding is this just requires the core functionality of the draft, not the any of the optional functionalities. Is that accurate? Or am I missing?
That's correct. Yeah, this part is just a standard one. I have another diagram in 2 slides with extensions.
Okay, I just want to make sure I understood correctly of which portions of these scenarios that you're trying to enable require the extensions and which don't. Thanks.
Absolutely, that's a great question. That is perfectly without any extensibility demultiplexing required. Tommy?
All right, hello, cool. I think the audio is working now.
Yep, I can hear.
Just to chime in a little bit to respond to Ian, though, as we've been looking at the different options for how you communicate, like if contexts are optional and stuff, that does have an impact on how you send the early data and what capsule types are allowed. So it's just something to keep in mind. This should be possible with any of the setups, but sometimes there are constraints on what you can send in this first flight, depending on how you negotiate extensibility.
Yeah, I actually have some slides to discuss this in coming right up. Thanks, Tommy. So the order of the slides is kind of a little bit of a mess. I'm kind of jumping back and forth, and I apologize for that. So as we were saying, some of these extensions, they want to be able to send multiple formats. So what's the simplest way to do that? You put an identifier at the start. So when you're receiving, you parse the identifier, and then you know which format, what parser you should use to parse this datagram. Is this just a UDP payload, or is this compressed, or does this have some additional data at the start or at the end? But if we're making this optional, you end up with an interesting conundrum, which is that identifier at the start present or not? Should I be parsing this identifier, or should I just assume that it's not there? And that question is where some of these complexities for that extensibility design come from, because in the original version where this was always there, it was a lot easier. But turns out we can make this work. So then this is what Tommy was alluding to a little bit. Now, this is when we want to do extensibility, but without a latency cost. So let's say you're a client, you want to talk to a proxy, and you want to use some extensions. Your main goal is to do connect UDP to a target. You still want to have your end-to-end quick connection through your connect UDP proxy, but maybe you want to use, let's say, the ECN extension. You just don't know for sure if the proxy supports it at the moment you start. So you kind of send your request and mention, potentially with a header or something as part of your request, that you're also going to want to use extensibility. And you still send your HTTP datagram. You just need to make sure to let the proxy know that this datagram, for example, doesn't have a demultiplexing identifier at the start, so there's no confusion, even if the proxy does or does not support this extension. And then it can, seamlessly, without a round trip, forward that over to the target and let you know with its response that extensions are supported on this connection, on this for this request. All right, so what is the current design we have? And that's, as we're always not set in stone, what we have today is Vinny, go ahead, sorry.
Slide understand, can you just clarify a little bit?
Absolutely.
So the proxy actually doesn't know anything about that extension in that scenario you described. It just allowed that extension to work end to end. Is that correct?
So let me clarify. That's a great question. What we mean in this case by end-to-end, because there are multiple ends in this protocol, and it does make things confusing. In this case, an extension would be between the client and proxy. So the client and proxy have to know about the extension. So let's say, for example, in the ECN scenario, this extension would allow, when the proxy is reading UDP packets from the target, those could have ECN markings on them at the IP layer between the proxy and the target. And this extension would allow the proxy to communicate those markings to the client as it's forwarding these encapsulated UDP payloads. Like, as it's sending a UDP payload, it could say, oh, this one was marked ECT0, this one was marked congestion experienced. So in the context of that extension, the ends are the client and the proxy. They're the ones that need to know about the extension. But if we have an intermediary in the middle between the client and the proxy, that doesn't need to know about the extension. Ted?
So kind of a clarifying question here on what you do then if you're expecting an extension to pass through the proxy and head on toward the target. And I'm thinking here about RFC 5795 style robust header compression for IP headers. So you can imagine using that in two different ways, one of which is saying, hey, I'm going to use ROC in my compressing IP headers to you, the proxy, or to tell the proxy that you expect ROC to go end to end to the target. So in that second case, I assume from this design, you wouldn't negotiate the extension through the proxy. It would then just take the connect IP payload and treat it like it was an uncompressed IP packet, send it out, and if it failed, that was on the client for not understanding what it was sending. Is that approximately correct?
Yes, actually. Sorry, Ted, I'm getting some feedback. Please use headphones or mute. So the extensions that are like transparent to the proxy in the sense that are client to target are kind of out of scope here because they'll work, but the proxy doesn't even need to know. So all the extensions I'm talking about are extensions between the client and the proxy. Like, for example, in this case, if there are extensions inside this end-to-end client-to-target connection, the proxy doesn't need to know or care. And it can't even because they're encrypted inside Quick. So when I say extensions here, to clarify, I'm specifically talking about extensions between the client and proxy where both the client and the proxy know about them. Thanks for the question. That wasn't clear.
That mostly does. I do think that there may come some cases where the proxy has to know that what's going on isn't malformed, because obviously IP with ROC headers and presumption of context looks different from standard IP, but it probably doesn't need to do a lot to support it. But I think this is probably not the main topic, so let's move on.
Yep. No, thanks. I think there's utility and value there, but yeah, that's not what we're trying to what I'm trying to specifically solve in these set of slides. Thanks. Ian?
Clarifying, I think, comment. The proxy here is what Echo referred to as a forward proxy, and the target here is one or more reverse proxies, machines, application front ends, yada, 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 that receive the traffic, right? Like, just to clarify, like the target could be like one or more machines, and we kind of don't care because it should just all work because like reverse proxy providers need to deal with this stuff themselves. Is that accurate?
Absolutely. So in this scenario, let's say you're using Connect UDP as like an IP blinding service. from the client and the proxy's perspective, the target is just an IP address on the internet and a UDP port that you're sending things to and that you're receiving things from. There's worlds of complexity and servers and machinery behind the target, but from our perspective, we don't know, we don't care. This could all be running on a Raspberry Pi on a corner, or it could be, backed by a giant Google data center, completely oblivious to us. We don't care. But from the client's perspective, there could still be an intermediary and a proxy, which, like, in general, the client doesn't really need to care. All it knows is it's trying to connect to a Connect UDP proxy with a given authority. What we just need to build here is make sure that if the entity that wants to deploy the Connect UDP proxy wants to deploy that behind a front end, in other words, behind an intermediary, that needs to work. In practice, it doesn't really change the protocol much, but it packs some design requirements, like the fact that we can't rely on settings for everything, for example. All right, so the
sorry.
Oh, go ahead, Ian.
So why can't we rely on settings here? Because I think I'm missing why we can't rely on settings.
Well,
I apologize for asking too many clarifying questions.
No. On the contrary, this is really useful because these are trivial points. Thank you. So you're in a given HTTP deployment, intermediaries are pretty common. So like take our setup, we have the Google front end, and then we have backends. So mapping to like the terminology here, the Google front end is an intermediary, and the Google backend would be the one implementing Connect UDP, and which would be the one that we list as the proxy. And that could be the egress to the internet in some scenarios. The settings are hop by hop at the HTTP layer, whereas requests are end-to-end in that scenario where the end is the proxy. You could be running something into that, but the request could flow through an intermediary, and we have folks in the working group that wish to deploy that this way, in particular for web transport.
So to walk back, let me try to reset this in more terms that like that are very focused on hardware infrastructure. So like in this case, like Google's running like a target, which is like, probably at least 2 and sometimes 3 layers of load balancers stuck in front of like an application front end. And you're saying that the first load balancer needs to make sure to communicate the right settings for all the things behind it, because otherwise like bad things could happen, right? Is that what you're saying?
So let's say I think the web transport example is perhaps a better one, where you have a front end, which is also a load balancer, and you talk through that to a myriad of backends. As a client, you don't even know that there are front ends and backends. You just know that the front end in other words, the intermediary served you with the appropriate proof for the TLS certificate, and when you send your request, you got a reply. Maybe it went through that to a different machine, but potentially, let's say some of the fleet supports this web transport with extensions. Some of it supports web transport without extensions. And the front end doesn't know all of the supported protocols, features, extensions of all of its backends necessarily. And so it can't synthesize a setting frame for you that covers everyone in the back. You need to go and send the request and get a response to know fully what they support.
But just to like kind of really like slice this down to like the very specific points. So the server, the load balancer needs to know whether, say, Connect IP, Connect UDP, Connect, or web transport is supported, because the way you load balance those protocols is just like transformatively different from standard HTTP. So like you're just not getting away without like having that knowledge at the terminating load balancer. But So
to clarify that, you need to, and that's specifically what we're picking at. So let me just clarify on what you're saying. The intermediary needs to know how to proxy HTTP datagrams, and especially for web transport has other custom things that need to be proxied, such as like custom unidirectional streams, for example. So the intermediary needs to be aware of this. But if we, for example, want to add in the future an extension, the goal there is that this front end that was modified once to speak web transport doesn't need to be modified every time we want to deploy a web transport extension. That is the key kind of distinction.
Okay, that makes sense to me. I think we should just move on because I think we've kind of gotten it down to the point where I just wanted to get it to, which is the load balancer does actually need to know like whether web transport, for example, is supported, but it's valid to say once web transport is supported that maybe there's some other stuff you want to like tunnel to the actual application front end that you don't want to make every single hop in the middle be aware of. So why don't we move forward through what the extensions are, and then maybe that'll clarify everything for me. Thanks.
Cool, will do. Thanks. No, that was a great point. And that was what I was trying to get across. But yeah, taking the time to actually state it clearly, really important. So thanks for your help. So yeah, the current design, how do we do this? It introduces the concept of datagram format types, which is okay, this is the semantics of my payload. So for example, in our current drafts, Connect UDP registers the UDP payload datagram format type. And the client starts off by by sending a register datagram capsule that says, hey, I'm going to be sending UDP payloads on here. Like those are the ones that you need to, when you get the payload, you then put that, you write that into your UDP socket to the target. And additionally, we have this demultiplexing mechanism, which is inside this box. And so you negotiate using the SecUse datagram contexts HTTP header, and the draft introduces the concept of a context. And the idea is when this is in use, every datagram starts with a varant that is a context. So for example, you could say, okay, I want to register the UDP payload context, and I want to register a UDP payload with 2 bits of ECN at the start context for the ECN extension. Or you could register the ICMP context extension. So then when the other side receives an HTTP datagram, it knows, it'll read this variant off the head and then say, oh, this is just a UDP payload. Let me put this into my UDP stack. Or this one, oh, I need to parse these first 2 bits for ECN. Or this one's kind of a separate sidecar of ICMP or something. And it knows how it can parse and what actions it needs to take based on this demultiplexing identifier at the start. And MT mentioned on the list that this is, he says that this is overly complicated. I don't disagree. And actually, we had a good conversation with him and others last week. And the fundamental thought that MT got across to you, which I think is very, very reasonable, is like concepts aren't free. When you mint a new concept, you have to keep it in mind forever. And if you ever got anything wrong in the definition of that concept, you're gonna like pay it for many years. So if we can get something even simpler, that's better. So we have an issue to track that. And we kind of came up with a new design that I just wanted to run people with. And then as soon as I'm done running through that, I'll have a slide and then we can like jump into a full discussion. Sorry. So the idea there is, I initially thought that like the datagram format type was our best extensibility joint, our foothold, if you will, to enable all this extensibility. But it turns out after some more thinking and discussion, it's possible to get the extensibility we need without introducing this concept. And I think that that's a nice property. We want to have an extensibility joint, but we kind of already have one in the protocol. It's capsule types. So as a reminder, capsule is this client to proxy protocol where you just send a sequence of TLVs, and the T there, this type, is something where you can mint new one. They're registered with IANA. And that's a really good extensibility joint because proxies and clients will drop any capsule that it doesn't understand. So a new extension, protocol, anything can define its own capsule. And so this PR 115, the idea is we remove those registration capsules because we don't need them in the core spec. We remove datagram format types and we add some text to say, okay, if you're an extension, you'll be able to use these capsule types as your extensibility mechanism. And so with this potential design, what you say is you send a header as part of your request to when you're the client and you want this demultiplexing functionality, you send that header. And if the proxy replies with that header as well, it means, okay, we both have like support at least one of these extensions. We think there's value here. We want this demultiplexing. So when we've negotiated that, now every single HTTP datagram starts with this demultiplexing variant, which we call the context ID. The idea there is that context ID maps to a context. For example, let's say if you're doing IP compression and you're like removing the IP addresses, this context would be a struct somewhere in your memory that contains the IP addresses that have been removed. So when you parse the incoming datagram, you put them back in before you feed it into your IP stack. And because we wanted this idea of zero latency extensibility, we add the concept of data. We add multiple capsules for datagram to convey the ones that explicitly have or do not have context. So the idea there is, while you're negotiating the headers, so as a client, before you've received the headers, you can't send the like regular quick datagram, HTTP datagram, because there could be some confusion about whether that variant is present or not. So until you know for sure and have gotten the server response, you use these separate capsules that are crystal clear. They're self-describing, in other words. And once you've known the response, then you know you both agree on what the format is. You can send this or not. Yes, Ian?
The shape of what you're describing sounds good. One kind of wording suggestion or comment is, we're using the word demultiplexing here. At any point, do you actually mean like an intermediary or a proxy or something like that, taking a single stream and then sending it to two entirely different locations? Or are you really talking about like, I might even call it like format conversion or compression or something like that, where basically you've developed like a better formatting for whether it's like ECN or IP compression or whatever, and the thing that terminates the proxy is which is in some sense an end-to-end hop, is responsible for saying like, okay, I understand this format and I know how to convert it to like, UDP or IP or whatever I need to pop out the other end. And so it's kind of, it's a format conversion, it's a compression. I don't know, like some of their, or is it actually multiplexing you or like load balance it differently?
So no, that's a great question. I'm using demultiplexing to say separating between multiple things inside an incoming flow of things. So that's horribly unclear. What I mean by that is, the goal isn't to say like, let's say you're a Connect UDP proxy. It's not to say these packets go here, these packets go there. It's let's say your Connect IP. It's this packet came here. That is an uncompressed IP packet. Let me just put it directly into my kernel IP stack. This one is a compressed IP packet. Let me first decompress it and then put it into the stack. So you're demultiplexing into your application parsing logic, not to necessarily a different target.
I think what you're talking about, David, this is not demultiplexing in the sense of going to a different piece of hardware. It's demultiplexing in the sense of going to the piece of software that knows what to do next with it.
Yeah,
exactly.
That's actually what I was, but I just wanted to kind of make sure that everyone was on the same page about that. Sorry, another clarifying question, please.
No, Ian, those are extremely helpful. Thank you. Cool. And so what does this mean in terms of the like design requirements that we were talking about earlier? So it's clear that this has this multiplexing for the definition we just talked about. It supports this well. It's clear that intermediaries are not involved as part of this at all. So you'd be able to deploy this later without having to modify the intermediary, which is really cool. It allows you, because it's done at the HTTP datagram layer, to have extensions such as Ben's MTU discovery extension that you can write once and then use for web transfer and Connect UDP and Connect IP. It has this zero latency property thanks to that separate capsule, but I want to insist a little bit on the optionality, because that's been the sticking point for folks who don't want this concept and who don't want to implement it. So I went through the mental exercise of, if we took all this like demultiplexing context, all this body of work, and ripped it out of the HTTP datagrams draft and created like an HTTP datagrams context extension draft, what would be the foothold that we need to make sure that we can like ship that later? And the only thing we need is those capsules that allow you to send things before you know what the server supports. And so right now, instead of having just a datagram capsule in the draft, you would move the datagram with context capsule to that extension draft, but you're still left with two in the base draft. There's the datagram one, which might or might not have the context, and the datagram without context one. So conceptually, maybe if we split it out of the draft and we didn't want to have the word context anywhere in this draft, we'd call it unextended datagram. And we would just require implementations of HTTP datagrams that are not extended to parse both of these capsules in the exact same way. Whatever you do, you get one or the other. You just take the payload and you parse it as a payload. And that's the only kind of foothold we need. And an extension can kind of slightly tweak these semantics and say, well, the datagram capsule might have the context ID if it's negotiated, but the unextended datagram capsule never has it. And that's a little the kind of the hack that allows you to send things during before you've gotten the responses. So my general idea is we've managed to pare this down to kind of the simplest thing possible. The only extensibility joint that we require that is a burden for implementations that don't care is that they need to understand two capsule types instead of one and put the exact same machinery. So you would put, two switch statements back to back when you're parsing. And I think, yes, that is the end of my long ramble about all these things. Now, let's bring everyone in for discussion. In particular, are there requirements that we've discussed here or that we haven't discussed that you care about and that you want? Or are there properties of the system that don't work for you for some reason? Or do you have any other random thoughts, comments, questions? And I think we have some agenda time. I haven't been keeping too much track. Eric, you can tell me how much more we have, but we have some time allocated for discussion here. Please come on up to the mic line. Go ahead, Eric.
So I think we're going to try to time box this to about 15 minutes. And when we get to the end of that, we'll see where we are. If we've completely face planted, we'll go from there. And if we haven't, then that's wonderful. So let's try and keep comments as short as possible to let everybody get some time in.
Vinny, go ahead.
Ideally, the less complex this is, the better. So I like the idea that you've kind of constrained some of these things. I assume just standard, all the proxy authentication methods will work with Mask. Is that a correct assumption?
Absolutely. So Mask, in particular, in this case, ConnectUDP, but all other things we're discussing are traditional HTTP requests and responses. So ConnectUDP, now we're using Extend Connect. We'll talk about that in a minute, but you can send any HTTP header alongside it, including the pre-existing authentication headers. So absolutely, that just works that way. MT?
Clearly not. All right. I can't even see myself.
Okay, I can hear and see you, though it seems it's dark where you are as well.
Very dark mode, as Alan said. So this discussion, do you mind going back to the last slide where we talk about the requirements?
This one or the one that has just the requirements?
This just has a summary, right? You've got a couple of points here. And there's a lot here that's bound up with the design of the different protocols that are going to be using the H3 datagram stuff. And I've been sort of convinced back and forth throughout your discussion of all of these things about the virtues of some of these other things. But ultimately, what I think we want here is the ability to send a stream of data to the other end, bidirectional, and associate a bunch of datagrams with it. And that's it. The ability to fold stuff back in, the ability to add extensions, the ability to identify that this particular datagram belongs to this particular subcontext is something those protocols can deal with. And if the intermediary understood that protocol, then it can participate in that. If it doesn't understand that protocol, then it probably has no business in participating in that protocol. And we can have a much simpler design here, and probably a much simpler design all over if we just have those capabilities. And that means no capsules, period. And that would be something that I think we could probably make work.
So let's pick on that. One of the, and actually I didn't talk about this in the slides because that part has been in the draft for a while. So we have a datagram capsule, and the goal there is to be able to send datagrams over versions of HTTP that aren't HTTP3. And a pretty common deployment model that people have talked about here is that you're going to have HTTP3 from the client to the first intermediary, in other words, your front end. And then it's common for folks to use, let's say, HTTP2 from that intermediary to the proxy. And if, as a client, you're sending your datagrams in a quick datagram frame, the intermediary is going to have to convert those into a datagram capsule to be able to send it to the backend, in other words, the proxy. And I think that the idea here, or at least in the draft as it's currently written, is you have a capsule that is the datagram capsule, and the intermediary speaks that because it's going to need to do this conversion, and then kind of you're done. That way you don't need to reinvent this datagram capsule for each protocol. Is that what you're suggesting?
I'm actually suggesting that we reinvent them, because that it's not reinventing them. I mean, the idea is pretty simple, but the protocol that the intermediary speaks, that does involve folding datagrams into the stream or pulling them out again on a hop by hop basis, is something that can be negotiated on a hop by hop basis. This is something that Web Transport already does. You're talking about lifting stuff out of these protocols that are specific to those protocols and putting them in a framework, and then imposing that framework on everyone who uses datagrams in HTTP. And I think that's a poor choice.
So that makes sense. At the end of the day, the question there is, do we want to have a common way to do this across protocols, or do we want each protocol to do their own? My general sense, and I see more people getting in the queue, so is it feels silly to have everyone reinvent the same wheel when, like, folks seem to like capsules, because, you know, how can you get any more simpler than a sequence of TLVs? But yeah, I see that you and I don't necessarily agree on that one. All right, I'll jump to Ben in the queue.
Hi. There's a lot going on here. I think that it is getting a little confusing because we're talking about multiple layers that are really quite independent here. So I think a lot of people following this presentation may not have caught that the datagram format types are pretty much unrelated to the capsule discussion. That they run end to end and are not connected to that. I do think that we need to be clear that there are two kinds of intermediaries that we're actually discussing here. We're discussing essentially smart intermediaries and sort of dumb intermediaries. So we have smart intermediaries that can do this kind of HTTP version conversion magic with interleaving and deinterleaving to convert to, like, merge datagrams into a TCP stream or something. We also have dumb intermediaries that just forward things directly. And both of those are fine, but the case that gets you in trouble is dumb intermediaries that are trying to talk to an H2 backend. So imagine that I'm an intermediary. I've advertised H3 datagram support to the clients, because I do support H3 datagrams. But there's one of the backends that I talk to is H2 only. A protocol comes in. I don't even know what that protocol is. I don't know if it uses capsules. And so I can't forward these datagrams. And I also can't signal that the datagrams have failed. That's the case that worries me the most. And I will just float that if you think that all of this is too complicated, this complexity, a lot of this is because we're effectively reproducing a lot of the functionality of web transport, in my view, because we need it. And so if you think this is too complicated, I would suggest weighing the alternative, which would be to run all of this over web transport.
All right, thank you, Ben. Ecker?
Hi. So I think perhaps we have some disagreement about the requirements, which is I don't understand how you get into the state Ben suggests, which is to say you have been configured with the you've been configured with the URL and settings of an endpoint that you're connecting to. That endpoint, that should not happen if the situation Ben suggests in which you have been configured with that and then the backend doesn't work, simply should not happen because you should not be configured with it. And if it does, the answer is to send an error. So it's not like only discovery here is happening in settings because we're not discovering, it's not like we're discovering that you can use, compression. We are talking about a specific service which is configured to the client, either via some mechanism and advertised by the server. So what I'm saying is simply do not configure your system that way and the problem will go away. So the word intermediary appears in this document 30-ish times. It should appear 0 times. And the right answer is that the front end, the thing which you initially click connect to, should advertise only things that make sense. And it is its responsibility to translate the things that make sense to it, the things that make sense behind it. And so I guess I'm simply unpersuaded that any of this machinery is required. So I guess that I think that would be my put, I think that probably that's prefatory to any discussion of how to actually implement the functionality which people seem to be desiring here.
Thanks. I mean, that's in the sense that folks want to deploy this behind front ends, so intermediaries. One potential design is what you're saying is we terminate everything at that first hop, and conceptually then there's no more intermediary because you say that any protocol that supports HTTP datagrams must kind of terminate that request. It can send another request behind it if it wants, but conceptually those are no longer the same one. I don't think that particularly simplifies things, and my main concern there personally is that it means that now you can't, anytime you want to extend anything, you need to modify the front end as opposed to just the client and the back end. And given software update cycles aren't always the same on front end and back end, that could prevent you from deploying extensions down the road. And so that's why I would prefer an approach where some of this is transparent to intermediaries, which then means that the document needs to acknowledge that intermediaries exist.
I'm sorry, I'm going to need you to repeat that argument.
So let's say for example, let's focus on web transport. Folks want to deploy web transport on backends through a front end. I think that is going to happen. And there are 2 ways of doing that. You can either say the request is end-to-end from client to backend, and there is an intermediary, or you can say so that's like the design in the draft right now. What you're proposing, I think, is to say the front end terminates the request, and then it creates a separate disconnected request from the front end to the back end. And so what that means is then you no longer have discussion of intermediaries in the HTTP datagrams draft, because then you have HTTP intermediaries from client to front end and from front end to back end separately. And there is no sharing of state or anything between them. But what that means, however, is if you want to add any extension to web transport, you need, because the middle intermediary needs to support that extension, you need to modify it as opposed to only having to modify the client and the back end. Does that make sense?
Thank you. That helps. Yes. And what I'm saying, so I think what I'm saying is one way to do is to terminate, and the other way is to have a private arrangement between the intermediary, the front end and the back end, which describes exactly which parts of the channel are clear and parts of the channel are not clear, and that what's happening here is you're hoisting all that complexity on the client. Because you don't want to make that private arrangement between the server and between the origin and the intermediary. But the truth of the matter is that there are many such arrangements in many different configurations, and that I think the attempting to dictate the behavior of those intermediaries has proven to be extraordinarily difficult on both HTTP and SIP, and that it's far simpler simply to model them as B2B UAs. And that then the BBX can do everything that they want, and it's simply not a matter for standardization. So yeah, I think that actually imports into a lot of complexity later. But anyway, I think I see there's a queue behind me, so I'm going to stop.
Yeah. All right, thanks. All right, folks, I heard a bell ding. I think we're getting either close to or already out of time. So let's all try to be a bit quicker. Victor.
Yeah, I just wanted to say that, like, at some level, the way this models extensibility for things like ConnectUDP is that ConnectUDP is a resource, and fundamentally any extension to ConnectUDP that you negotiate is a property of an individual resource, as opposed to property of the connection. And to comment on Acker's point, I do think that proxy to backend requires standardization, because in cases like CDN, those are the objects that are operated by different entities, and even in cases that they're operated by same entities, they're often the software is implemented by different people, like, for instance, me running Nginx as a reverse proxy. So I do believe that we are fundamentally do need to standardize those, and that works for HTTP, so that should work for Mask or what.
So thanks, Victor. So to clarify what you're saying, you're suggesting that we have HTTP datagrams function end-to-end from client to proxy in such a way that we don't need to modify the intermediary to terminate things on the intermediary. Is that what you were saying?
Yes. I believe that, like, similar to things like HTTP headers, that those should be. Also, my thing tells me to stop talking, so I'm going to stop talking.
Awesome. Thanks, Victor. Alan?
Yeah, so the timer just expired. And there's been a lot of discussion going around back and forth. I think at this point it's fairly clear that there's a lot of different hot takes on what the draft should do, and what the requirements are, and what the simplest thing is moving forward. So what Eric and I would like to do is propose a design team to sort of resolve these particular issues, followed by an interim meeting between now and IETF 113 to present the results. And hopefully drive towards consensus. So if you would like to participate on this design team, please either send Eric or myself an email, or just drop a note in the chat, and we'll make sure you're on it. David, since you've been so instrumental in moving this draft forward, wondering if you'd be willing to lead the effort, and help make progress.
Yeah, happy to. So folks, if you want to, like, I don't know, apply, type DT plus or something in the chat, I'll make sure to gather everyone's names, and then we can have a side meeting sometime soon. So that
Eric and I will help coordinate logistics to make it easier for you all to focus on the technical details rather than dealing with time zones and whatnot. So thank you. In the interest of time, Alan, Lucas, Tommy, if you have clarifying questions that still can be asked, or you still like to ask, of course you can ask them. But if the things that can be punted to the design team later on, I encourage you to do that.
All right. Thanks. All right. Lucas, you're still in the queue.
Yeah, I just want to say that the decision, like people have been arguing about getting rid of capsules, but if we do that, we're back to where this draft started, is HB3 datagram. The whole point of adding capsules was to support datagram over HTTP2, which was a use case people wanted, and HB1 as well. So if we're revisiting that, it would make me sad, but and I'd want to know why, and we can have that discussion in the design team or later ones. So thanks.
Cool. Thanks, Lucas. All right. Let me see. Where was I? Right. So I had another question for this draft about, oh wait, no, that's, there was an alternative proposal and a discussion on reliable datagram, but I think I'm going to punt this to after that, after the design team, because there's no point going or even resolving this until we know next. So let's kind of switch gears and talk about Connect UDP for a bit. So where are we with Connect UDP? So the Connect UDP draft was kind of on hold for a while we were, redesigning HTTP datagrams, and then we kind of, since we landed on a vastly different design for HTTP datagrams, I took some time to update Connect UDP to reference that, and also to update some of the discussions we had in the past. And the main change there is that Connect UDP is no longer the Connect UDP method. It is now the Connect UDP HTTP upgrade token, which is the registry of things you can use with upgrade in H1 or with extended connect in H2 and H3. So we now say Connect UDP relies on extended connect, which is RFC 8441 in H2 and a draft that's currently in the HTTP working group for H3. And the idea is the server sends a setting to say, I now allow a new pseudo header, which is the colon protocol header. And so you send a connect method with a colon protocol, and you send that with Connect UDP. So that was one of the major changes to the draft, which we had discussed pardon me, in the previous meeting. And it kind of simplifies things, and people were saying that it'll also be easier to deploy given existing infrastructure. And then another important change was configuration of on the client. So let's say you want to tell your web browser, for example, to use this Connect UDP proxy. Before you would just give it a host and port. And now we say we use a URI template. So at the bottom of the slide here, I have like 3 random examples of how you would configure the client. And conceptually, what it means is that you send the target. So the target, again, is the server that you want to proxy to in the path pseudo header when you're sending it. And the important distinction there is, so in almost every HTTP method under the sun, the authority is the authority of the proxy, and then the path is how you tell what you want, your actual target, what you want to talk to. Connect was its own beast, where in the authority, instead of having the authority of the proxy, you had the authority of the target, the host name and port of the target. A lot of folks were saying that design choice for Connect was odd, and we didn't want to replicate that for Connect UDP. So here we're back to a more traditional HTTP design where the authority header contains the authority of the proxy you're talking to, and then the target is encoded in the path. So right now what we have in the draft is a URI template for this. So that said, the URI template was something that I forgot who proposed a few IETFs ago. When I went to implement this for the hackathon last week, it was way more of a pain than I thought it ever could be. So for folks that I've read the RFC on URI templates, there are very complicated ways of encoding URI templates, and I mean, it's okay, don't worry. It's not like anyone has introduced security vulnerabilities by having mistakes in their parser before. And so my thought was, do we actually need a URI template here? Because the really cool properties that we rely on is the property that we have a URI for configuration, but it doesn't necessarily need to be a template. Because if we have a URI for configuration, it means that the scheme is decided at configuration time, and that also conveys the authority of the proxy at configuration time, which you obviously need. And it allows you to rely on the path. So for example, you could have behind the same authority multiple paths for proxying, and you could pass in, as a HTTP query parameter, like the user name or whatever you fancy. And so the question is, do we want to, how do we send then the target host and port that you want to connect to? Do we send it in the path with a URI template, or do we say no, the path is reserved for like just configuration elements and it's sent in a separate header? I initially thought the URI template was really great, but it ended up being way more complex to implement, and that wasn't great. And I'm not sure we should replicate this. So URI template really made sense for something like Do, because it allowed you to just type in your query into like curl and get a response like directly from the command, which was really neat. That's not something you're going to want to do for Connect UDP. And the other property is so in the Connect IP draft Tommy will be talking about later, we decided to mimic Connect UDP. At the end of the day, let's try to keep them as close to together as possible. But the URI template parameters were different. So I thought it would be really cool that you could configure your mask proxy with one configuration string, but if you're using a URI template, you can't really, or you need all those parameters in there. So if we have a URI for configuration and not a template, and we use headers, you can then reuse them for multiple mask methods, which I thought would be kind of neat. So I personally would be inclined to switching to headers. What do folks think about that? Empty.
Here, and why would you move resource identity to a header?
Sorry, you still need to wait like 10 seconds before your mic starts working. Can you repeat the beginning of that, please?
So I guess the question that you want to ask here is, what resource are you identifying here? Are you identifying a generic resource that's got the ability to connect to anything, such that having different IP addresses in the URL would be a mistake? Or are you identifying a resource that has generic connectivity properties?
And that's actually, that is exactly the question that we're trying to answer from so I was asking it in terms of like practical, wire encoding matter. You're asking it in terms of like conceptual matter, but I totally agree. It's the same question. Are we saying that we are like the resource we're, in HTTP terms, the resource that we're going to, is that the part of the proxy that handles Connect UDP? Is that the resource, or is the target the resource? And if the resource is the target, then we want this to be encoded, like the target host and port to be encoded in the path. If the resource is the proxying capability, then we don't want it encoded in the path, we want it encoded in a separate header. That's the question we're trying to answer here.
Yeah, but might you want to have different access control depending on the destination that you're going to? That suggests a URI.
I mean, you can perform access control based on those other headers as well, right?
You can do all sorts of interesting things with headers. But when you start to use those headers to identify resources, then they're no longer really headers anymore.
I agree, and I guess conceptually, I'm saying that maybe the resource isn't the target. The resource is the proxying capability. Vinny?
A couple seconds there. Can you just elaborate on how you envision header parsing being simpler than template parsing? Like I didn't understand that point. They're both going to have the same kind of parser type bugs would happen in both, right?
No, and that's a great question. I guess I should have been more clear. So right now on the client, so I need to parse the URI template. So you're going to have to run some code on the client, which as input is going to take the configuration and the target. So let's say your configuration is a URI or a URI template. That's how you refer to the proxy. And you're going to take at the moment, your browser is saying, I want to connect to this target over there. So you're going to take those two bits of information and combine them into an HTTP headers frame. And so right now, what you need to do is parse the URI template in order to, like the technical term from that RFC is to expand the URI template into a fully resolved URI. And so you're going to need to, if you're using a URI template, look at the line at the bottom. You're going to need to understand that is a level 3 URI template, where you're going to have to say, okay, well, my authority is proxy.example.org port 443, and my path is /mask target host equals 1.2.3.4 ampersand target port equals 1, 2, 3, 4. And that's that parsing that you need for a URI template. Whereas if we used the URI, regular URI for configuration, you wouldn't need that, because you would take the URI and you would parse it just in order to split the authority off from the path. You put the authority in the authority pseudo header, you put the path in the path pseudo header, and you put what separately you got as your target IP into its new header and your target port into its new header. That also makes parsing on the server, on the proxy side, easier, because now you don't need to go and parse some of this to get the IP address. You just say, well, I look at this header and there it's there. I don't need to split it out in any way. Ecker.
Oh, right. I'm waiting. I forgot. So, I mean, I guess I don't feel super strongly about this, but I also don't think that the arguments you're offering are very persuasive. You know, you have like an X509 parser, so like I don't think the additional security like overhead of parsing the URI template is like that big a crisis. I do note the comments about how complicated it is. I thought Lucas's suggestion that maybe you should profile as level 1 would be fairly persuasive. I do think from a philosophical perspective, which I mean is not necessarily determinative, the header is wrong. I mean, the verb is connect. The resource is the thing you want to connect to. And if what you were wanting to say was that the thing you're connecting to is somehow the proxy, then and that reaches the proxy, then the verb should not be connected to something else. And you know, we already have this worked example of regular connect, which is how this works. So I guess that's like not dispositive necessarily. You know, one could argue that HTTP should not have been designed the way it has been designed, but like I think if we're aiming for some full, so I think that I think the argument you're offering that this is like a pain in the ass, I think it has some merit, but I think the argument that that it's that philosophically it should be in the header, I think as well.
I agree with you. I mainly care because it was a pain to implement. At the end of the day, that's what I'm trying to minimize for. I'm an implementer. The conceptual aspects of HTTP are not my personal main concern. Ben?
Waiting for audio. Okay.
Yep.
So just to remind people, URI templates mandate full Unicode support. So a URI template can contain any Unicode code point, which then has to be escaped and normalized down to the URI char set. That happens after substitution, so you can have supremely weird interactions here, like a RTL reversal Unicode code point that sometimes appears depending on the template contents, or there's unlimited weirdness there. Also, URI templates can template any part of the URI. You can template the scheme. You could have template the port number. You could have the connect UDP port target port number actually be the origin port number, or you could have it be a subdomain of the, or even part of a domain. You could register all 65,000 domains. Like anything is possible with URI templates. It's just a little bit of a warning. I'll just note that there is an intermediary, there's a middle ground option here where we say that everything has to go in the URI, and we actually specify the URI structure a little bit rather than just templating it.
Cool. Thanks. Tommy?
Waiting for audio. Cool. Yeah, so I think I agree with what people are saying. Implementations that support Do already need to support URI templates. People who are doing Mask probably also support Do. So it shouldn't be too much of a new lift. To Ben's point about weird URI template types, I mean, I think we could, if it hurts to do that, don't put your things in the scheme. Like, we should probably have some constraints here to say, like, hey, we're already using the scheme, we're already using the authority and the port, so like you can't put your target there. Sorry. For Connect UDP, I can see where you're coming from here, but when we go into Connect IP, as you alluded to, and how we want to kind of align these, I think it's a stronger argument for why these properties are part of the resource. Because in something like Connect UDP, I could very well have a generic VPN that doesn't have any constraints on what I'm connecting to. It's totally open-ended. And I have one that only forwards SCTP packets or whatever, and like those are very reasonably different resources that I'm accessing. And so I do think the logic is clearer there, but then you can kind of back apply it into Connect UDP and say, yeah, this really is the resource you're connecting to. And if you wanted to split up your server to think of it as different resources that you're accessing and have different access control that way, it would make sense. So I think we should leave it in the URI and maybe just add some constraints to the crazy things you could do with a template that are just wrong.
Okay. Thank you. Yeah, sounds like from the folks in the mic line, there's some interest in keeping this in URI templates. All right, moving on to our next and final issue for today. In Connect UDP, since now we are so for H2 and H3, we use extended connect with the colon protocol pseudo header. The method is connect. The protocol is Connect UDP. What do we do for HTTP 1? Right now for HTTP 1, we use the upgrade mechanism. And we say, so at the end of the day, this mimics WebSocket, which is the only standardized use of extended connect that I'm aware of. And so we say, okay, same as WebSocket, you can do Connect UDP over H1 by using upgrade. But the question is, what method do you use? Because when you're using upgrade, conceptually, you don't look at the method, you just look at what you're upgrading. The only kind of purpose is to say, oh, what happens if you accidentally hit a server maybe who doesn't support upgrade? Like, what flavor of failure would you prefer to have in that scenario? And so right now, the Connect UDP draft says you use connect with upgrade. WebSocket says you use get with upgrade. Which one should we use here? I personally don't have an opinion. Do folks have thoughts? All right, well, if no one cares, we can keep it as we have it today in the draft, and we can always change that later. Martin.
So if I understand correctly, if we ran into a server that didn't understand upgrade, then we would just end up sending datagrams that would become random bits somewhere on a TCP connection coming out the proxy, whereas with GET it would just sort of return a 404 or something, correct?
Let's see. Well, with GET, you would end up sending a GET with a body, which is technically not allowed. So, yeah, I guess that would probably be it. Where with GET, you would end up, well, not necessarily a 404, because someone could,
Sure.
Yeah.
So, some error code. What I mean, that seems strictly better than like this undefined behavior with connect. Not undefined, but just this sort of spewing random bits out.
Yeah. Well, I mean, and actually, so connect, you send a HTTP1 connect, you send an authority without a path, whereas here you would send connect with, there would be a slash in there, and now, it's always hard to imagine what kinds of bugs exist, but someone would probably sending what's with this slash to get at our info or something. So I'd expect that it would fail spectacularly at the DNS resolution or trying to parse the IP stage, as opposed to trying to create an outbound TCP connection to that something.
Right. Well, I don't know that we need to like analyze the failure path here, but and other people have written more HTTP parsers than me, but like, I mean, I would just say just whatever has a more deterministic and less goofy failure path would be the way to go here. Thanks.
Totally agree, because the new thing we build will work, whatever the method we use. It's just if we hit random, so maybe we just need to do some homework and hit a bunch of existing servers with what this would look like, and see in what way things fail. Eric?
It seems like if we're going to be using extended connect for a bunch of things, then we may want to be kind of figure out what we're going to be happy with living with long term there and pick something and be consistent. I guess another option here would be a new method like connectx.
Agreed. I think we should be consistent between Connect UDP and Connect IP and other things. I would prefer not to create a new method, because that's always work. And but yeah, let's definitely be consistent. MT?
So one option here is to ask HTTP Biz what the answer is, because this is a problem they currently are examining in some part with the HTTP3 integration or extended connect. Maybe this is a generic problem for HTTP and not one that Mask needs to preempt.
That sounds great to me. Okay, unless someone dislikes that idea, I'm going to take the action item to email the HTTP list asking them what they think. And I see some +1s in there. Perfect. All right. And this brings us to the end of this presentation. Thanks everyone for listening, and good luck until dawn for everyone who's with me on the West Coast. All right. Thanks everyone, and over to you, Tommy.
All right. Okay. Hello, everyone. I will be presenting a new unified draft for Connect IP, IP proxying support for HTTP. All right. So Connect IP, I think we've heard this many times bounced around the working group before. Why is this different? And mainly the difference is that we have had many different versions of the proposals from different authors. And over the past couple months, those different authors and myself have tried to join forces and come up with a single proposal for what Connect IP should look like. So yay for unification. So just to recap the motivation for all of the Connect IP work in general, we want to be allowing, truly generic IP proxying through an HTTP proxy, not just what we get from Connect and Connect UDP, which is limited to TCP proxying and UDP proxying. And this, if we look at the requirements document, which was adopted and worked on by this group, a lot of these use cases are what we traditionally think of as VPNs, whether those are kind of just a user using a VPN for privacy, a remote access into an enterprise, site-to-site VPN. That's a lot of the driving use cases that constrain this space. But you can also think of this as just a Connect-like proxy for an arbitrary IP protocol. And to that end, it can have a lot of similarities to Connect UDP. And I think as the authors looked at it collectively, a lot of the differences in perspectives were because we had some perspectives coming from the purely VPN side and some coming from the side of saying, this should be a Connect protocol for arbitrary IP. So I think we've tried to reconcile those two worlds and end up with something that is fairly simple and straightforward. So as we discussed with the authors as we were coming together here, we agreed on a couple things as the scope of this. So, right now it's defined as an extended Connect protocol mirroring Connect UDP. We believe that if Connect UDP changes its approach, this should also change its approach. So we just want to keep those things aligned as much as possible. We want to follow the best practice there. For kind of simplicity, getting the base of what Connect IP is, the proxy always is dealing with entire IP packets that are contained within the content of HTTP datagrams. Compression could be done in some future draft, but the base definition is always entire IP packets. And then another key thing that the authors agreed upon was the fact that, it sounds quite simple when you think about it, the Connect IP document should be concerned only with things that exist in an IP header itself. And that's the kind of the unit that they're operating on. So the different endpoints can request and assign and route based on fields that exist in the IP header. So that's the source address, that's the destination address, and that's the next protocol. We could also add other things in if people decided it was necessary, but these are kind of the core elements that make sense. What is out of scope is trying to do any IP header compression now. That should be an extension. Things like ICMP signaling, we agreed, should probably be another document. That would be a useful extension to have both for IP and UDP connect methods. And there are also fancy things we could do in which we could get a bit more next protocol aware and understand what we do for different port allow lists for different VPNs, but that should also be an extension. Okay, so what actually is defined in this document? And it's not too much, thankfully. First, there's the upgrader protocol token Connect IP, which mirrors the stuff that David was just talking about as Connect UDP. So that's really just a lift and rename. Currently, it's also using a URI template to be able to scope things down if necessary. Now, in this case, it doesn't make sense to talk about a target name and a target, or a target host and a target port, because there are no ports. Instead, you have essentially the target host that you want if you have one, or you can have none, and a target next protocol if there is one, or it can just be generic and get anything. There are a couple different capsules defined. This is using capsules really as just a negotiation mechanism so that you can, after the time of request, over the stream be able to add and remove addresses and routes. And so there are 3 capsules defined only. There's an address assign, which allows one endpoint to tell the other side, you can send from this address when you want to generate a packet. You can also have an address request, which is, I would like to send from this address or this subnet. And then in the same way that address assign can define the source address for packets, a route advertisement capsule defines the destination that a site is allowed to send. So you can say you are allowed to send to anything essentially that falls within this routing table I'm going to give you. And then the last thing that's defined in the document is currently it's called the datagram format because the HTTP datagrams document still has these, but essentially it's just saying the thing that goes within a datagram is a full IP packet. That's it. Extensions can do something else if they need to. One of the concepts in here that we discuss a lot that isn't necessarily immediately obvious is that there are uses for limiting the routing and being able to communicate that you aren't able to route a full tunnel. So a lot of the simplest VPN use cases that we think about are essentially when a client device receives a single address or a prefix to send from, and then it can send to everything in the world. However, there are a number of different use cases where that can be more restricted. Maybe you have a split tunnel VPN, or you're just only trying to reach something very limited on the other side. So there are different ways you can limit the scope of a tunnel. You can, in the request, specify that you only care about a specific target and protocol. Either endpoint can also limit what the other can send from with its address assign, and then the route advertisement capsule itself can limit the set of destination addresses that an endpoint can send to. And besides being a good mechanism for access control and being very clear about what's going to be allowed, this also allows a proxy that's operating a bit more like a normal Connect or Connect UDP proxy to be able to share source IP addresses between multiple clients. So if one client really only is trying to talk to a specific host or a specific subnet, maybe it's not trying to open up a completely full tunnel scenario, then you don't need the same type of IP address provisioning requirements that you would as a normal VPN. So that's essentially the protocol as it stands. I have a couple examples here so we can just see how this looks. So the traditional VPN setup, I have a client behind my proxy, my VPN server. It has some IP address, IPC, that can go out to the world and talk to any arbitrary address. So the way this would look is the client starts a connect IP. Currently, it registers this datagram context that may and hopefully will change. Then the other side can just send back a 200 and say, hey, you can send from this address and you can send to pretty much anything you want for that address family. And then at that point, the two sides can send datagrams back and forth to each other, and those are full IP packets. So this is quite simple. You could also have a case where the client is only interested in talking to a single host on the other end. Maybe it's just trying to open up a SCTP flow for some reason. And in this case, the protocol works exactly the same, except you can get back a very limited route that only is the thing that you requested to connect to. And at that point, the payloads are still full IP packets, but they're only going to be IP packets that are going to that one particular host. And then the last example we have here is just showing how you could use this even if you're connecting to a specific host that you can receive different address families to send from, because we like supporting both v4 and v6, and you can get a routing table that supports both. Anyway, so that's the protocol.
Tommy, just one clarification.
Oh, sorry, Jana.
No, not at all. that is supposed to be proxy, not server, right? Just making sure that not
yes.
not keep things, trying to keep things less confusing. I'm confirming that you mean proxy
Yes.
there.
It
Okay.
should, yeah, we can change it to proxy. It's the server from the
For
perspective
the
of proxy
mask
protocol.
connection, I
Yes.
understand that, but really, yeah, I mean, I think proxy is probably the terminology I've seen in ConnectUDP. It might be good to unify that as well to make sure we're not going.
Yep, that's
off
a good
here.
point.
Thanks.
All right, so that's essentially the scope of this. We've tried to keep it very simple. So I think the questions to the group now are, is this the right starting place for doing Connect IP? And if so, is this ready to adopt? Or do we have other questions that we think need addressing? Ecker.
Yeah, I think this is a pretty good starting point. I think it's probably good enough to adopt. I sent some technical comments in email last night.
Thank you.
You just eliminated them completely because it felt like midnight, but or something. But actually, I think there was more like 3. But anyway, yeah, I think those are all things we could hash out in some later discussion. So I think this is a good starting point.
Great, yeah, and I did see your comments. Thank you for them. I think there's stuff we can discuss. I think we can go either way on a lot of them.
Yeah, I'm not proposing to discuss them now unless for some reason the chairs are like in time permitting.
Yep. Any other comments? David.
I just wanted to say, like, I really wanted to thank Tommy for all the work he's been spending as editor to unify the 2 Connect IP proposals here. I'm very happy that we've landed on something that works for everyone. So just wanted to thank Tommy for all the hard work here. I'd love to see this get adopted now that we have kind of one proposal with the backing of a lot of folks, as opposed to 2 separate ones pulling in different directions like we had at the last IETF.
Awesome, thank you. All right, and yeah, it sounds like in the chat people are generally supportive of this. So I guess chairs, do you want to do something now or later?
Yeah, so thank you, Tommy, for the presentation. And we're going to use the show of hands tool. So everybody find this tab and go find where this is. But effectively, the question we're going to ask is this a suitable starting point for working group adoption? And you're going to be able to raise your hand if you think that it is, or you can actively choose to not raise your hand if you think that it is not. So we're just going to do one show of hands where you can choose up or down. And that should be open now. Give it a couple of seconds for people to find the buttons. All right. So we seem to have pretty strong support for using this as a starting point. Would anybody who chose to not raise their hand like to join the queue and potentially give any thoughts or reasoning as to why they made that choice? And we'll take that as a no. So we will take this to the list and confirm on the list, but thank you all for raising your hands. Next up, we have Ben. Are you ready? All right, if you request to slide. It's the one immediately to the right of the Q button. We do not yet have audio for you either.
Yeah, Ben, you're muted.
Okay, how are we managing slides?
You can
click-
share them yourself if you click the little share preloaded slides button. Looks like a piece of paper.
Yeah, the button is called Ask to Share Slides for us non-chairs.
Indeed.
Okay, can somebody tell me where that might be?
The Join Queue
Next to
button
join.
up left, just to the right of that.
Okay, ask to share slides.
All right, you should now be able to pick your slide deck and then you can advance at will.
Okay, great, thank you. Okay.
Lovely, we see.
So this is about, this presentation is about an individual non-adopted draft that I wrote in response to some previous discussions about path MTU discovery. And it's very much premised or phrased in terms of the current datagram format and capsule system. So to the extent that the design team decides to make changes there, this also would need to change. So ping is an HTTP datagram format type, and pings flow between a client and an origin, or we can also call it a proxy. Intermediaries, if they exist, don't care about ping. They are, again, in the terminology of the H3 datagrams draft, these are opaque datagrams. And they look like this. Each datagram contains an even number and some padding, and the response contains the next number and no padding. Very, very simple. They can go either way. Once you've established a context for them, they can be sent and echoed in either direction. Okay, why? The main purpose of this is inspired by Connect IP. Connect IP, in order to be a fully compliant implementation of IP, needs to be able to supply some minimum MTU. And so this gets tricky if you're running over a link that's already at or close to the MTU. If any of the links on the chain between the client and the backend have low MTU, then what currently the way this needs to the way you can solve this is by sending that datagram reliably. Well, okay, so we can get to that in a second, but basically endpoints need to be able to detect that there's some datagram that, like, the IP layer is officially able to rely on. So like this datagram is less than 1280 in IPv6, so it is guaranteed to be deliverable, but actually it's not, because when you wrap it in all of the mask overhead, it exceeds the underlying wire MTU. So we need to do something. We need to change what we're doing. But in order to do that, the endpoints need to know something about the path MTU. And because of the presence of intermediaries, using, for example, the MTU estimated by the underlying quick session is not going to be good enough. And there are even more complicated intermediary arrangements, like when the backend is actually speaking to an intermediary over HTTP2. So there isn't really a relevant transport MTU on that hop. But this is a very general mechanism. Anything that uses datagrams needs, in general, to know something about the MTU of that datagram path. And also, it's very, very common to need to know something about the round trip times and packet loss rates. And so it's a very general problem, and so it seems appropriate to have a general solution. So this draft is seeking working group adoption in Mask, although I don't think it's ready for that, especially given the sort of turmoil in the underlying drafts. I think we're going to have to revisit this. I think it's most valuable as a test case. So, these are problems, and this is the solution that kind of falls out from one set of design choices about how datagrams and formats work. And I think that hopefully that can help inform the design team as they consider that design space. You know, try to figure out, well, what are you going to do about these MTU issues? Do you want a solution that looks like this datagram ping, or do you want something else? And another thing that's important to note here is that in the design as considered here, it's important for clients and servers to be able to identify when a datagram needs this kind of protection. It needs this extra special end-to-end reliability because it's too large for the path MTU, and be able to send it that way. And right now, we don't have actually a mechanism in the current drafts that really allows that. And so we've had some discussion on the mailing list about, do we need a mechanism like this, or do we need to require intermediaries to adopt some more sophisticated behavior in order to make it possible to deliver those reliably, or indeed, do we need intermediaries to adopt a less sophisticated behavior that would enable that end-to-end property? So yeah, that's all I have for slides. Magnus?
Yes. So I think it's an interesting mechanism. I don't think it really solves the toughest case at all of the path MTU discovery, especially if you're going to run DPLP MTUD over your mask tunnel, you get before I can tell if the actual flow is supported or not, you're going to have a delay because first you need to probe is the MTU supported, and then you can make a decision about it. So I think it has some significant downside to try to solve that issue, but it maybe be solving it faster, of course, means more complexities in the intermediaries. So
yeah, so there's this learning MTU is always asynchronous. It always takes, you never know it before you start. You always have to wait for it. And the question is, how long do you have to wait?
Yeah, but there's one crux, I think, in this, which is particular to mask or any tunnel protocol in some sense, in that you will know what the MTU are for the first hop, for the first quick hop, in some sense. But
if you're speaking quick on that first hop.
Yeah, but not intermediates and forward until the end of the peer, so to say, the mask peer. That's where you run into the trouble when you have intermediaries on the HTTP layer. So
yeah.
But I guess it's for continued discussion of this. I mean, how we solve it, and I think it's one of these requirements that should be considered in the design team. Is to include that MTU question there.
Yeah, and one thing that I would want to emphasize is I think this illuminates one of the questions that's come up a lot with the design team, like why can't we just use settings frames for everything? If you try to use, for example, if you tried to use settings frames to communicate the MTU of the H3 datagram, so the setting says this proxy supports datagrams up to this size, then that implies knowledge of all of the paths to all of the backends of that proxy. So it's not just about compatibility with all the proxies, it's actually also about all of the network elements that stand between them. Okay.
Ben, we still have Martin in the queue.
Sorry, Martin. Yeah. Last comment.
Ben, thanks for thinking this through. I think if nothing else, it's been a useful exercise to exercise this, as you said. But I guess what I'm wondering is if you have a protocol running over mask.
Yeah.
I mean, typically these off-the-shelf protocols will presumably have their own PLP MTUD mechanism, and they also have the advantage of not only probing the mask MTU, but also all the way to the origin server. So, what is the actual utility of having this utility in mask itself?
Sure. So the fundamental problem here is that the IP RFCs say that in order to be a compliant IP implementation, you must have an effective MTU of at least 1280 for IPv6. And while transport protocols running over it are allowed or encouraged to use path MTU discovery, they are also allowed explicitly to simply cap their datagram output sizes at 1280. If you never produce output greater than 1280, the IP specs say that you do not have to do any path MTU discovery. And so if we want to be a compliant implementation of IP, then we need to always provide functional delivery of packets of size 1280. That's an actual if, right? We have the option of saying this is an almost complete implementation of IP. And one thing that it doesn't quite give you is the MTU guarantees. And so you actually need to do some PMTUD for smaller sizes.
All right. Thank you, Ben. And Lucas, is 5/4 minutes useful, or do you want to punt to next time?
I think I could squeeze in 15 slides in 2 minutes.
Go for it.
Cool. Oh no, I pushed the wrong button. I don't want to do that. Here we go. Okay, so this is about datagram priorities, which is probably a low priority given what the Mask working group wants to work on. This was originally intended to be presented at the last meeting, but got pushed off because we ran out of time. Hence why I just wanted to use any time here to mention it and to see if anyone's really interested or if we don't care right now. I have a draft, an ID. It didn't take much work to write up, and it's going to expire soon. So if no one's interested, we can just leave it and maybe mothball it and pick it back up when the time's right, if that time ever occurs. So briefly, there's a lot of background here. We won't go into that, but Quick doesn't specify anything about prioritization of anything. It says you probably should do it, but it doesn't specify how. The datagram draft that's now post WGLC is defines the frames, but doesn't talk about priorities of them. HB3 doesn't define any priority signals either, and that's post working group last call. And the new Mask HB3 datagram draft that we have also doesn't say anything. So we're kind of bouncing around. We have different issues raised on different draft that have all been closed to say, well, the princess is in another castle kind of thing. Go look somewhere else. You got people like pointing at each other and saying, well, maybe we should. But I think with all the drafts we have today, we're fine actually with not saying anything about priorities. And so that raises some problems for anyone who's tried to implement something based on datagrams where they're being multiplexed with streams as well, or even logical flows of datagrams might need different priorities, and they have different needs and they need to be scheduled differently. Otherwise, certain kinds of problems might happen. So I wrote this draft just to get the idea out of my head. This is based on the extensible priority scheme. I don't necessarily think it's the only way to do things or the right one, but it is a way to do things. We'll skip the recap here. The philosophy of this design is that datagrams may have a different priority than the stream that they're related to. And this is only at the HTTP layer, nothing else. So there's some flexibility here, but sensible defaults. There's no per context prioritization, which kind of skips some of those problems that came up earlier. The proposal is just a new parameter that gets defined. It's similar scale to this urgency parameter that's already in priority, kind of decorates things and inherits from it. This is all in the specification. The question I was going to pose last time is, should we adopt this? But I'm thinking right now, the question is, who cares? We could have an adoption discussion later on when people have actually read this. Maybe Mask isn't even the correct venue. I'm happy if, with whatever people might think if they've had any time to look at it. So that's it. Thank you very much for your time. I see Tommy in the queue.
Yeah, if I have time for a clarifying question. You mentioned how, explicitly this is a different priority than the one on the stream data. Just what is the rationale for not just letting this stream priority be the priority here? Because like for Connect UDP, it's almost all going to be datagrams anyway.
That is effectively allowed if you say that you support this scheme as like a server, for instance, and the client doesn't send anything, the default is to inherit the stream's priority. So this effectively just makes that abundantly clear that people would go with that kind of flow. You could equally say that without putting it in any specification.
Okay.
All right. Sorry to abruptly shut the queue, but we're at the top of the hour and the end of the meeting, and folks have to get to the next one. So thanks everyone for your time, comments. We'll follow up on the list with action items regarding the design team and adoption of Connect IP. And we'll see you at the interim/next meeting and on the list. Thanks all. And thanks for our note takers.